Hello friends, my name is Sushil Pandey. Welcome to my networking video series. Today topic network essential books. In this part, we will study network models and identify the different layers of the OSI network models and identify the different layers of the TCP/IP network models. Let's start. What is network models?
Network models. Network communication involves data exchange or transmission over a transmission medium. Data transmission is a structured process and was initially described using the Transmission Control Protocol/Internet Protocol, TCP/IP, protocol stack. Later, a simple model known as the Open Systems Interconnection, OSI, model was developed. As a network administrator, it is important for you to learn about these network models to understand the flow of data in a network. Knowledge of network models will also help you to set up, manage, and troubleshoot networks and network devices. This chapter describes the OSI and TCP/IP network models and their purpose and benefits. Objectives? In this chapter, you will learn to identify the different layers of the OSI network model. Identify the different layers of the TCP/IP network model. Identifying the OSI model. The OSI model was developed by International Organization for Standardization, ISO. This model defines communication in an open system network, a network that supports multiple communication protocol suites developed by different vendors, such as IBM registered trademark, Apple registered trademark, and Novell registered trademark. Before the development of open system networks, the devices of one vendor were not compatible with those of another, and consequently communication among these devices on a network was not possible. The OSI model divides the entire communication process into 7 tasks, each of which is grouped into 7 different layers. Each layer is a collection of related functions, protocols, and devices that work on that layer. Each layer is designed to link the layers above and below it. In addition, a layer provides services to the layer above and requests service from the layer below it. The following figure displays the 7 layers of the OSI model, from the lowest to the highest. Layers in the OSI reference model. Next, the various layers are discussed in detail. Understanding the physical layer. The physical layer defines the means for transmitting data packets over a physical medium. The physical layer also describes the electrical and mechanical characteristics, such as the voltage, frequency, and transmission medium, of a network. The physical layer receives fully formatted data packets from the data link layer above it and sends the packets to the transmission media. A data packet in the physical layer contains a header, data, and trailer. The following figure displays the structure of a data packet in the physical layer. Understanding the data link layer. The data link layer sends data packets between computers over a network. The data link layer adds both header and trailer information to the data before sending it to the receiving computer. It is the only layer that adds trailer information to data. After sending a data packet over a network, the data link layer waits for an acknowledgement from the receiving device or computer. The following list contains the common functions performed by the data link layer. Understanding the network layer. The third layer of the OSI model is the network layer. This layer addresses the data packets and routes the packets from their source to the correct destination on a different or same network. The network layer uses addresses of the destination to send data packets. Some of the protocols that are part of this layer are Address Resolution Protocol, ARP, Internet Control Message Protocol, ICMP, and Dynamic Host Configuration Protocol, DHCP. These protocols are discussed in detail at the end of this chapter. Routers work at the network layer. Routers are used to connect multiple networks. When a router receives a packet to send to a destination, it works as per the specification of the network layer to determine the path the packet should take and forwards the packet to the destination. The following figure displays the working of a router in the network layer. Working of a router. Understanding the transport layer. The transport layer, the fourth layer of the OSI model, is responsible for maintaining, setting up, and tiering connections. The transport layer provides both reliable and unreliable data communication. The transport layer provides error correction for reliable connections and error detection. Understanding the session layer. The fifth layer of the OSI model is known as the session layer. This layer checks whether the data remains on the local computer or remote computer. The session layer is also responsible for differentiating multiple connections and forwarding events and data. This layer also specifies procedures for the connection, termination, and re-establishment of sessions. The session layer performs the following three types of dialogues. Simple. Understanding the presentation layer. The presentation layer encodes data sent by devices and applications into a standard network-compatible format. This layer provides services such as data compression and encryption. Some of the protocols that work in the presentation layer are Secure Sockets Layer, SSL, and Transport Layer Security, TLS. These protocols are discussed in detail at the end of this chapter. The following table lists some of the technologies that work in the presentation layer. Understanding the application layer. The application layer is the seventh layer of the OSI reference model. This is the layer from where communication starts and ends. The application layer provides the interface for a user to interact with different persons, with the help of applications, software. The applications we use to transfer data or gather data work at the application layer. Application layer implementation can be in the form of graphical user interface, GUI, or command line interface, CLI. For example, when you are accessing websites, the browser you are using is an application and it works at the application layer of the OSI model. Some of other application protocols are Telnet, Secure Shell, SSH, File Transfer Protocol, FTP, Simple Network Management Protocol, SNMP, and Simple Mail Transfer Protocol, SMTP. Common protocol. Understanding the OSI communication process. Data communication through the OSI model involves four key steps in which data from the sender travels through each layer of the OSI model until it reaches the receiver. The following figure displays these steps in the OSI communication process. OSI communication. The following detailed steps describe data communication. Identifying the TCP/IP model. The TCP/IP model is another protocol stack used in networking. The TCP/IP model gets its name because of the two very popular protocols that it supports, TCP and IP. The protocols and services included in the TCP/IP model are more practical to implement than those in the OSI model. The TCP/IP model contains 4 layers. The following figure displays the layers available in the TCP/IP model. TCP/IP model. Identifying layers in the TCP/IP model. The TCP/IP model contains 4 layers: application, transport, internet, and network interface, also called link. Each layer in the TCP/IP model performs a specific function. Each of the 4 layers is discussed in detail. Application layer. The application layer is the topmost layer of the TCP/IP model. This layer is responsible for application protocols such as Dynamic Name System, DNS, Hypertext Transfer Protocol, HTTP, Telnet, Trivial File Transfer Protocol, TFTP, FTP, and SNMP. The application layer interacts with the transport layer service to use the network. The application layer provides interface to users for communication with the networks, such as a web browser you use to access websites or content on the network. Transport layer. The transport layer is the second layer of the TCP/IP model. This layer is responsible for providing transportation to the data segments across the internet layer and is responsible for end-to-end communication on the network. To provide a reliable connection, the transport layer uses a 3-way handshake, multiplexing, and windowing. Internet layer. The internet layer is the third layer of the TCP/IP model. This layer provides connectionless communication across networks with the help of IP addresses. This layer is also responsible for routing data on the network. The internet layer works with the transport layer when receiving and sending data to the network interface layer. Network interface layer. The network interface layer is the last layer of the TCP/IP model. This layer is just like the physical layer of the OSI model. This layer provides access to a physical network. The purpose of a network interface is to allow your computer to access the wired or wireless network infrastructure and send data to other computers. The network access layer transmits data on the physical network. The following table displays different LAN and WAN technologies that work in the network interface layer. Understanding the TCP/IP protocols. The TCP/IP model performs data delivery and receipt by using a group of complementary protocols and standards known as the TCP/IP protocol suite. This protocol suite includes many universally accepted protocols and services. The TCP/IP protocol suite also defines how applications on separate nodes establish a connection and track communication. TCP. TCP is one of the core protocols of the TCP/IP protocol suite. TCP is one of the 2 major protocols of the TCP/IP protocol suite. TCP works in the transport layer of the TCP/IP suite. TCP is also a connection-oriented protocol. The TCP protocol is used for the World Wide Web, WWW, email, HTTP, and Hypertext Transfer Protocol secure, HTTPS, because it is the most reliable form of communication. TCP works on a three-way handshake principle, which is used for reliable connections and for making sure that the remote end receives data. IP. IP is the most important network protocol used on the Internet. It's used with the Transmission Control Protocol. IP works on the principle for assigning logical addresses to devices that can be used to transfer data and communication. There are two types of addressing schemes used in IP: IPv4 and IPv6. IPv4 is the most common version used today. It is a unique number assigned to a device for communication. An example of IPv4 is 192.168.1.200. IPv6 is the next version of IP, which was introduced as the successor of IPv4. The exponential increase in the networking technology consumed most of the address ranges that can be used as per the IPv4 standard. To cope with this challenge, IPv6 was introduced. The address size of IPv6 is 128 bits. Usually, an IP address in IPv6 is represented in hexadecimal form. An example of an IPv6 address is one of 5F0000:0000AF0005:06 of 3CDF3F6B. UDP. UDP is one of the main protocols in the TCP/IP protocol suite. It is a connection-less protocol. Unlike TCP, UDP is not a reliable protocol because it does not receive acknowledgement from the receiver after receiving the data. This is why UDP is also known as a connection-less protocol. Some examples of UDP communication are voice over IP, VoIP, and online video and audio streaming. Since there is no three-way handshake in UDP, data transfer is fast. FTP. FTP is the most common protocol used today to transfer files on the Internet or on the network. This protocol carries data and guarantees that data will be delivered properly. This is an example of reliable communication. FTP uses the ports 20 and 21 for data communication. FTP runs in either active or passive mode. In active mode, the client computer creates the TCP connection and sends the IP address and the port number to the server. The port number used for data transfer in active mode is 20. In passive mode, the client computer uses port 21 to receive the server IP address and the server port number. After the client receives the IP address and the server port number, the client opens the connection between the two devices to transfer data. TFTP. TFTP is the simplest form of file transferring protocol. TFTP uses port number 69 and it is designed for small data transfer tasks. TFTP is mostly used in networks to create a backup of routers, switches, and firewalls. TFTP is very easy to implement and use. TFTP uses the UDP protocol to make data transfer fast by removing the overhead of additional information in TCP. The earlier version of TFTP was used for 32 megabytes data transfer. However, it is now extended to 4 GB. HTTP. HTTP is used by www as a mean for communication. HTTP is used to define how data is transmitted and formatted. HTTP uses TCP to provide reliable data communication. HTTP works on port number 80. HTTP is also called a stateless protocol because each of its commands is executed independently. HTTP is the protocol used by all the browsers to access websites. HTTPS. The HTTPS protocol uses port number 443 for communicating data securely. HTTPS provides authentication and encryption and uses Secure Socket Layer, SSL, to provide secure communication. HTTPS is the most common protocol used by banking and financial companies to protect their websites and provide secure banking solutions to their clients. Telnet. Telnet is the most widely used remote management protocol used for managing network devices. Telnet also provides authentication features such as usernames and passwords for accessing devices. Telnet uses port number 23 for communication. Telnet, by default, sends data in clear text format. Telnet is used to manage devices remotely and internally or externally on the network. Internet Message Access Protocol. Internet Message Access Protocol, IMAP, is an application layer protocol. IMAP is one of the two most important Internet standards for email retrieval, the other one is POP. IMAP is used by most of the servers for transferring emails from a server. IMAP server uses port #143 for communication. IMAP has different versions being used today, for example, IMAP2, IMAP3, IMAP2BIS, and IMAP4. SMTP. SMTP is the communication protocol that controls the transmission of email messages over the Internet to the destination server. It is used by mail servers to send and receive email messages. It is, however, typically used by client mail applications only for sending emails to a mail server. SMTP uses the store and forward process, which means if an email receiving device is not online at the time a message is sent, SMTP can store the message until the receiving device comes online. When the device comes online, SMTP contacts the device and delivers the message. If the device is online at the time a message is sent, the message is delivered without storing it. SMTP uses the standard TCP port 25. RDP. The RDP protocol is proprietary to Microsoft. RDP provides a graphical interface to remotely manage other computers or devices in a network. RDP uses TCP port number 3389 for communication. RDP is used to remotely access devices or other computers on the network. You can also send RDP requests to users by using email for remote assistance. Networks administrators use RDP to access services such as DNS, email, and storage from servers remotely, without physically logging onto the servers. RDP can also be used by administrators to troubleshoot issues on host computers. In addition, RDP can be used to remotely manage multiple network devices from the same computer. The latest version of RDP 7.1 is being used in Windows servers, such as Windows Server 2008 R2. SSH. SSH is a cryptographic network protocol used for secure data communication. SSH uses TCP port #22 for communication. After Telnet, this is the most widely used remote management protocol for accessing network devices remotely. SSH uses encryption, authentication, and key exchange protocols for secure transmission. DNS. DNS is used to perform one simple task of converting IP addresses to domain names that can be easily understood by everyone. To resolve the IP address, the client DNS service contacts the DNS server in the network. For example, when you open the website www.yoursite.com, the computer uses the DNS service running on port 53 of the server to resolve the IP address. If the specific DNS server contacted by the computer does not have the IP address for a specific domain name, it contacts the next DNS server. This process continues until a proper IP address for the specific domain name is found. DHCP. DHCP runs on UDP port 67. The DHCP service is used in the client/server model to assign a dynamic IP address to the devices on the network. The DHCP service makes it easy for administrators to assign IP addresses to multiple machines for network communication. DHCP automatically assigns IP addresses to devices from the address pool created by the administrator. For example, you have 100 computers in your network and you want them to be on the same subnet for data communication. However, it will take you a lot of time to manually assign IP addresses to all the devices and computers. DHCP helps you in this situation and dynamically assigns IP addresses to all the devices and computers from the defined address pool. ARP. ARP is used to resolve the network layer address into the link layer address. ARP uses broadcast to search for layer 2 and layer 3 address information. Then, it resolves the logical address, IP address, into the physical address, MAC address. For example, you have purchased a new switch from Cisco. You have connected the devices to all the ports. Now the switch will send broadcast in the form of ARP out all of the Ethernet ports to learn the MAC address of the devices connected. ARP checks the MAC address of the devices and fills the CAM table of the switch. In the switch, ARP works on FFFFFFFFFFF and for layer 3, it is 255.255.255.255. Real-time transport protocol. RTP is widely used by media companies for delivering audio and video data over an IP network. RTP uses communication and entertainment media such as streaming media and video conferencing. RTP uses random UDP ports from 1023 through 65,535. RTP is used in VoIP networks for telecommunication companies for real-time data transfer over the Internet. Session Initiation Protocol. SIP is an application layer signaling control protocol. It is used to establish, modify, and terminate multimedia communication sessions, such as VoIP. SIP supports both unicast sessions and multicast sessions, which can consist of one or more media streams. SIP is not dependent on its underlying transport layer and is capable of running on TCP, UDP, and SCTP. Session Description Protocol. SDP is used to describe the content of multimedia communication sessions in VoIP for session announcements and session initiation. SDP can be used in a range of networks and can use multiple transport protocols, such as SIP and HTTP. POP3. POP3 stands for Post Office Protocol, used by email clients to retrieve emails from the servers. POP3 uses TCP/IP port hashtag 110 for data communication. POP3 is version 3, which was created after several versions. Most email service providers such as Yahoo, Google, and Hotmail use POP3 and IMAP services. Network Time Protocol. Network Time Protocol, NTP, is one of the most important protocols in networks. NTP uses UDP port number 123. NTP is used to synchronize time between network devices in the network or over the internet. The current NTP uses NTP version 4, v4, for synchronizing the time. NTP uses the server and client model, in which you set the time and time zone on the server and all the other client devices are synced with the server for accurate time. Internet Control Message Protocol. ICMP is used mostly by operating systems and applications to check the reachability of the devices in a network. Its protocol number is 1. ICMP is used by a ping utility to check the reachability of the device on the network. For example, you are using a computer with the IP address 192.168.1.54/24 in the network and you want to check the reachability of the server with the IP address 192.168.1.85/24. You can use the ping utility and check the reachability of the server. IGMP. IGMP is a communication protocol used by hosts or devices on IP networks to establish multicast group membership. IGMP establishes host memberships in specific multicast groups on a single network. Next, IGMP allows a host to inform its local router by using host membership reports that it wants to receive messages addressed to a specific multicast group. IGMP works above the network layer but not at the transport layer. TLS. TLS stands for Transport Layer Security. TLS is a secure socket layer protocol that uses asymmetric keys to transfer data securely over a network. TLS provides privacy and data integrity to packets. TLS handshake protocol uses authentication between the client and the server. TLS also uses port hashtag 443 for communication and its different versions are TLS 1.0, TLS 1.1, and TLS 1.2. These versions were enhanced to increase security of packets.